0.4, you're going to have to do something that will follow you for this year and for next year. It's something that will disappear when you get to calculus, which is kind of nice 2 years from now. But for the next year, this year and next year, you are going to have to rationalize. That's the word of the day. Rationalizing means that you're going to remove radicals from the denominator. As a matter of fact, it doesn't mean that you're going to get rid of them entirely. It means that they're going to get out of the denominator and move primarily to the numerator. As you move to calculus 2 years from now, there's even going to be a way where you unrationalize and move radicals from the numerator to the denominator. That will help you as you're finding limits and things like that. But for now, we got to start with the basics. What we're going to do is we're going to rationalize number 1 together. And the process that we use for rationalizing on square roots will be the same. And then we're going to apply it to third roots, and we could even use it for fourth roots and fifth roots and things of a higher degree. So here we go. To rationalize, we're going to multiply the fraction by 1. And I say 1 in quotations because you're not really multiplying by 1. You're multiplying by something that is equivalent to 1. It's the same radical to the top and the bottom of the fraction that would create a rational denominator. Here's what I mean. Because this is the square root of 3. And I have a square root in the denominator, I need to rationalize it. I need to get rid of that square root of 3 in the denominator. Here's what I can do. I can multiply this by another root 3 over root 3. What is root 3 divided by root 3? Let me put this red piece here in parentheses. What is that equal to? What is root 3 divided by root 3? It's equal to 1. 1 times anything is itself. That's the multiplicative identity that you've learned since you learned your multiplication tables. 1 times 10, 10. 1 times 5, 5. 1 times 6, 6. 1 times this is still going to be itself. 1 times anything is itself. But this is going to allow us to do something. When you have the square root of 3 times the square root of 3, and since in 0.3 you've learned how to multiply these two things, do you have a pair? This is the root 9. Will it break out because you have 2 factors? Yes, it breaks out. So your denominator would then become 3. Your numerator, you have an outside and an inside. They don't mix. So it's 1 root 3. The easiest way to write that is root 3. And a rationalized number 1 is root 3 over 3. It no longer has the radical in the denominator. How did I know I was going to multiply by a root 3? Because that's what I needed to get a pair of 3's to pop out of the denominator. If this was 1 over root 5, wait, I'm not going to say that one. If it was 1 over root 4, I'd multiply by root 4 over root 4. If it was 1 over root 7, I'd multiply by root 7 over root 7. I'm hoping you see what to do. If you see what to do, I want you to try number 2, see what you get, and then I want you to compare your answer with the person you're sitting next to. If you're at home watching this video, I am going to let this record and just keep going until everybody is done. So you may want to fast forward watching this video. Go ahead, try number 1. Or try number 2, I'm sorry. What do you get? Compare your answers, please. Have all of you checked? Did you all get the same answer? Ooh, I hear yeses. If you got the same answer, please say your answer out loud. What was on top?
5.
What was in bottom?
5.
Perfect. So most of you got root 5 over 5. I'm going to put that in a box right there for number 2. And show of hands, how many of you got that as your answer? I'm curious. It sounded like it. That's every single person in this class, 100%. Good job. Just in case you didn't, we multiplied by root 5 over root 5. You have a pair. It pops out. Perfect. How does this get harder? This is the basics of what we are going to do. It gets harder because we then can add some fractions where there are things in the numerator and things in the denominator, like number 7. I'm going to make a recommendation to you. You know how I've been trying to show you the fastest way to do something. There's ways where you can do it, and you'll still get the same answer if you were to rationalize this right away. But sometimes you might save one step if you take this shorter path. If a fraction is inside a radical, you can split the radical to the numerator and the denominator, or vice versa. Meaning, if I'm square rooting a 25 over 6, this is the same thing as the square root of 25 over the square root of 6. That might help you when you're dealing with the variety of problems you will see in your homework. Try to simplify first prior to rationalizing. What that means is if you can make it smaller first before you rationalize, and I'll show you a couple of different examples in just a second. Number 7. When I look at this, does 6 go into 25? Nice and even? No?
No.
Okay. So then what I would do is I would look at this, and before I decided to rationalize, I would probably split this to the root 25 over root 6, because that's what that means. That's what I mean by you can split the radical. You're taking the square root of 25, the numerator, and you're taking the square root of 6, the denominator. You can go from this to that or that to this. It doesn't matter. Now, can I make any of these smaller before I rationalize? Does one of these simplify? You see it? What should be in the top? Say it out loud. I can tell you understand. So you simplified the top. That takes out one of our radicals, which is a good thing, but this is not rationalized. Rationalized means we have no radical in the denominator. So how do we rationalize? I need to multiply by something. I'm going to multiply by some component of 1. Something over itself. I think you might know what it is. I hope you know that you're multiplying by root 6 over root 6. If you're not multiplying by root 6 over root 6, then you're doing something wrong. If you only write 1 root 6, then if you only just did this in your homework or your test, you would not give full credit. Because you cannot just multiply by root 6. That is not, where did that come from? Can I multiply by a 1? You can multiply anything by 1. It's itself. Does that make sense? If you only show me one of them, it's not full credit. It's partial credit. So keep that in mind. And then I have a pair in the bottom, which means the 6 can pop out. The top doesn't have a partner, and one's on the outside and one's on the inside. So I write it like 5 root 6. And I know that answer doesn't look more simplified, but it is mathematically. 5 root 6 over 6 is the correct answer. If you understood how to do that, I want you to try number 8. And you may discuss the answer with number 8 with the person you're sitting next to. Make sure it's rationalized and simplified. Go for it. that? I'm looking for where you go. Okay. I would recommend that you make smaller to simplify that before you actually. They'll save you a small step. Simplify it all? The numerator? What a variety of different answers I have seen. Okay. I sampled about 30% of this class as I was walking around. I wanted to see what different answers I saw. Some of you were close, some of you were right on, some of you took the long way. Some of you didn't even know where the path was, but that's okay. Okay, here we go. Let's talk about something I wrote down, and I want you to know what it means. If you can ever simplify first, it makes your life easier. So before I even did number 8, remember what I asked you when we did number 7. I said, does 6 go into 25? And you said, no, it doesn't. If you can simplify it, always simplify it first. Does this reduce? Does 2 over 18 reduce at all? What does it reduce to? So that is the same exact thing as the square root of 1 over 9. Now, if you did this in a different way, that's okay. I'm going to show you the shortest way, and then I'm going to show you the longer way that I saw some of you do. And I know that this is the square root of 1 over the square root of 9. Do I know what the square root of 1 is? Do I know what the square root of 9 is? My final answer should be 1 over 3. You may have taken a longer road, but you can still get to the same answer. I'm curious, how many of you got 1 over 3? Raise your hand. Ooh. By a show of hands, there were about 4 out of the 35 students. So that's a good indication that I need to reteach this. Here we go. If you did this, let's do it the longer way. Let me do the longer way in a different color real quick. If you did this, you can still get the same answer. Some of you split it apart. Okay? Root 2 doesn't break down. Root 18 does break down. Let me break it down to 9 times 2, 3 and a 3. So maybe you wrote 3 root 2 over root 2. If you did that, maybe you noticed that you have a root 2 over root 2, and maybe you noticed that those would simplify, and you got 1 over 3, and you got the same answer. I don't think a lot of you saw that. Did anybody see that by chance? Okay, nobody saw that. So here's what I'm going to assume you did. Let's just go away from that. Root 2 over 3 root 2. Maybe then you multiplied by root 2 over root 2 because you need another root 2 to break out. Do you have a pair? What happens? The 2 pops out. You now have 6 on bottom. What happens over here? You have a pair. The 2 pops out. What does 2 over 6 simplify to? So no matter the long road, the short road, you will always get the same answer as long as you keep going until it's most simplified. That's the good news. No matter if you went this route or this route, I'm showing you the shortest route. And why did I go with that shortest route? Is because I tried to simplify first. Does that help a little bit? I'm hoping it opened your eyes. Oh, okay, I see how to do that. You're going to get more practice with that. That's what the homework will be for. Moving on. It will be somewhat the same idea when we start moving into third roots and fourth roots and things like that. Just like before, when I said simplify first, I want you to start thinking about making things smaller before you make them bigger. When I look at number 11 and I see 1 over the third root of 49, I want you to know that 49 breaks apart. I want you to think of this. Let me go back to red because it just shows up so much better. Don't think of this as 49. Think of this as 7 times 7. Because when you make things smaller, then you realize I only need 1 more 7 to have a triplet. Now I need only 1 more third root of 7 in this group so that it could break out, and then I would have no more radical in the denominator. So what we're going to do here that is different, we have a third root. We need 3 factors. Guess what I get to multiply by here? I multiply by another third root over third root. And I need how many more factors to have 3 factors break out of this denominator? I'm hoping you see it now. If I multiply by, technically I'm multiplying by 1. I'm multiplying by the third root of 7 over the third root of 7. Now I have 3 of these, which will pop out, and you just get a 7. And notice I say pop out, I don't say cancel, because the word cancel means it disappears and goes away a lot of times. It doesn't go away. I still have to write 7 down there. Don't forget that. On top I have the third root of 7. That is our final answer for number 11. I want to show you something so you can learn from mistakes of past Honors Math 2 students. There will be some Honors Math 2 students who will do this. I need 3 of these 49, so I'm going to multiply by 3 and then another 49 and another 49. Guess what? You can do that. Okay? On bottom, guess what pops out? A 49. On top, guess what we have? We have a, I don't know what 49 times 49 is. But what I do know is that I would have to simplify that. Because 3 factors, and this is 7 times 7, and this is 7 times 7, so I have 4 of them, right? If you factor out 3 of these, and then outsides can reduce with outsides, you can get to the same answer. Look at how much more work there is if you just multiply by, oh, I need 3 of them and here's 2 more. That's why I say up here, simplify first. Go with the smallest thing. You can save yourself a whole lot of work if you simplify first. I'm hoping that makes sense. Here's number 15. I want you to try number 15 and compare your problem or your answer with the person you're sitting next to. Go for it.
Sample of Cora's class, and we are all over the place.
I sampled about a quarter of you, and there were different answers all over the place, and I gave a lot of hints to the people that I saw, and so let me go to the shortest road first. The shortest road is always going to be the path of least resistance, but you can get there by going the long road as long as you keep going. Let's look at 15. What I would do first is I would have that third root over the 8 and then the third root over the 9, because 9 does not go into 8 evenly. It doesn't reduce. And I know that the third root of 8 is the same thing as 2 times 4, 2 times 2. That breaks out, there's 3 of them. 2 over the third root of 3 times 3. And then, because I know 9 is 3 times 3, I just have to multiply by the third root of 3 over 3. which means my final answer is 2 times the third root of 3 over 3. And I'm curious, how many of you got 2 times the third root of 3 over 3? Raise your hand. Oh, we're getting better. Excellent. Almost 50% that time. Way better than just 4. Now, for those of you who went and did something different, let me see what I could think that you might do. I saw somebody multiply by 2 more groups of 9. I saw some people try to rationalize the numerator. We don't rationalize the numerator, just the denominator. There are other ways to do it. This is the shortest road. So before I move on, what questions do you have about what I did that doesn't make sense or you're confused on? No questions. We have 2 more examples, and then we'll take a break. The way that I made these notes last year was I did your homework first, and then I thought to myself, what do they need to know in order to be able to do the homework? That's really how I made the notes when I was writing them up. And so when you see something like this, where it says 18 and 19, I recommend that you rationalize, then find a common denominator and combine if you can. The reason why I wrote that down was because as I was doing number 18, I thought, and number 19, I thought, they could find a common denominator and then put that together and then simplify. And then I was trying to think of the shortest path possible. And once again, that's what I came up with. Rationalize first, then find a common denominator, and then combine if you can. That's my recommended order of doing things. So we will do number 19 together. I did not choose 18 because I wanted you to try number 18 on your own. And then we'll do number 20, and then we'll call it a lesson. Number 19. I cannot add these together because they are 2 fractions and they do not have a common denominator. So I'm recommending on number 19 you rationalize first. So let me rationalize these 2 things. I am going to rationalize this side by multiplying. Ooh, wait a second. Before I multiply, I know that 4 is the same thing as 2 times 2. If I break it apart, then I don't have to multiply by as many of them. So I'm going to multiply by the third root of 2 over the third root of 2. And I say that because as I was walking around before, there were students who were multiplying by square roots and not third roots. They have to be third roots to multiply the other third root over itself. Now this side, the numerator is going to be the third root of 2 over, I have 1, 2, 3 factors of 2. They pop out. Boom. The other side, third root of 7. 7 doesn't break down. Therefore, I have to multiply by a third root of 7 times 7. That means that this numerator, when there's nothing to simplify, you put it back together, is the third root of 49. This denominator is 7. So I've rationalized first, then I recommend finding a common denominator. Still can't add these. They don't have a common denominator. But now because the denominator is a 2 and a 7, I think it becomes a little bit easier. The common denominator is 14. We cannot clear fractions. We don't have an equal sign. So now what I do is I multiply this by 7 over 7. I multiply by 1 again. And this side I'm going to multiply by 2 over 2 to get a common denominator of 14. Bless you. This numerator, the left side, is 7 times the third root of 2. The other denominator is 14. The other numerator, since 2 is on the outside, it does not go to the inside. It stays in the numerator. And we now have 7 bless you, times the third root of 2 over 14 plus 2 times the third root of 49 over 14. We have a common denominator. And combine if you can. I'm going to put these over a common denominator. I can only add radicals if they have the same index, root 3, and the same radicand. Do they have the same radicand? This will not simplify at all. So literally, the only other way you could write this answer, it's a really ugly answer for that matter, is this way or split up this way. I would accept either of these two answers as your final answer. You cannot put them together if they're not the same radicand. So you leave it that way. I know that's a little bit funky, but there you go. Last example, number 20. Number 20 combines what you did in 0.3 and, go ahead.
For the previous question,
yes.
We have multiplied the 2 times the 49 to get 98 and then divided by 14.
This 2, you're talking about right here, right?
No, the answer.
The answer.
If we times the 7 by the 2, we get 14, and then we can times the 2 by the 49 divided by 14 to get 7, or 14. No, 7. Sorry.
Yeah, I don't think that there's any, it's this or this, but if you were to simplify over here, you go right back to where we were right there. And so you don't know if these are going to go together until you get to the end anyways. So right now, this is kind of what I'm going for 18 and 19. Number 20, on the other hand, combines today's lesson with yesterday's lesson pretty well because you're multiplying things. And so just like before, if you can make things smaller, then do it. I would simplify it. If numbers are on the outside, you multiply them. I see a 2 times 5. I'm going to put 2 times 5 right there, which is 10. I have 3 on the outside. But before I multiply the 8 and the 5, I'm going to break apart the 8 into those numbers. Then what I'm going to do is I'm looking for a pair so I can simplify. I'm going to pop out a 2. I notice before I even rationalize, I'm still trying to simplify. That 6 and 10 can reduce. I can divide by 2 and divide by 2. I'm going to just write that over here like divided by 2, divided by 2. Outsides and outsides can reduce. So right now I know this is 5 over 3 root 10. Just trying to make it smaller first. That's pretty much as small as I can make it. But what I'm going to do next is I'm going to rationalize it because I have a square root or a radical in the denominator. I need to get rid of that. I'm going to multiply by root 10 over root 10. These 10s, there's a pair, so it's going to pop out. I'm just going to write 10 like that. Some of you are going to want to multiply the 3 and the 10. But I see something here. Since the 5 and the 10 are both outside, I can reduce that as well. So my final answer is going to be root 10 over 6. The reason why I chose number 20 is so that you can have an example while you're doing your homework. That you can look at this and go, oh, I'm supposed to do something like that. I'm going to stop your notes right there.